Welcome back at C Squared. In this lesson, we'll talk about how to prove a quadrilateral is a parallelogram. And the definition of a parallelogram, if you remember, it's nothing else than both pairs of opposite sides are parallels. And that is one way to prove that a quadrilateral is a parallelogram. That is the definition. However, there are more ways to prove that a quadrilateral is a parallelogram. And let's see the first one. If both pairs of opposite sides of quadrilateral are congruent, then the quadrilateral is a parallelogram. Another way is this one. If both pairs of opposite angles of a quadrilateral are congruent, then the quadrilateral is a parallelogram. A third way is this one. If the diagonals of a quadrilateral bisect each other, then the quadrilateral is a parallelogram. And the last one is this one. If one pair of opposite sides of a quadrilateral is both parallel and congruent, then the quadrilateral is a parallelogram. So now let's see some examples, some problems, and let's take a look to this first one. And we have to determine whether each quadrilateral is a parallelogram, and we need to justify the answer. So let's take a look to A, and what do we notice here? We notice first of all that AD is parallel with BC. How do we know that? We notice these two arrows here. But also we notice that AD is congruent with BC. If you remember, this is one of the theorems that allows us to say now that yes, A, B, C, D is a parallelogram. Why? Because a pair of opposite sides are congruent and parallel. And that is one of the theorem we just had. Let's take a look to part B. On part B, we need to be careful, because if you notice, yes, these two sides are parallel, but then these two sides are congruent. Okay, that doesn't mean this is a parallelogram. And I'm going to draw here a picture to prove you a case where this condition will not have a parallelogram. This is an isosceles trapezoid. These two sides are congruent and these two sides are parallel, and this is not a parallelogram. Okay, so this is a counter example, if you want to call it like that. So in this case, we cannot say that MNTP is a parallelogram. And this second example, we look into part A, and we notice we have what here? We have these two sides are congruent. AD congruent to BC, and also we notice DC congruent to AB. And if you remember, that is one of the theorem at the beginning of this lesson. And yes, we can say now A, B, C, D is a parallelogram. Yes, if the opposite sides are congruent, then the quadrilateral is a parallelogram. Let's take a look to part B. On part B, obviously, we have only these two sides congruent. Only two sides congruent. So we cannot say about E, H, G, F that is a parallelogram. In fact, if you remember very well, the trapezoid we had in the previous problem is a good counter example even in this case. On my next problem, we're gonna look to find the value of x and y, so we're gonna have to use some algebra that quadrilateral ABCD is a parallelogram. And now we see we have some expression for AE, CE, BE, and DE. And what do we need to look at? Here we look to this AE and this EC. So what is the condition that will allow us to say that this quadrilateral is a parallelogram? We should have AE congruent with EC and also BE, and let me put these segments here, BE, I apologize, congruent with ED, because that means the diagonals bisect each other, and that is a way to prove that the quadrilateral is a parallelogram. So now I'm going to write the second statement here, AE equal of AC, right, the definition of congruent segment, which brings us the equation for x plus 28 equals 6x minus 10. I will subtract 4x here to get rid of this 4x. Of course, on the other side, do the same thing. Then we have 28 equals 2x minus 10. I'm going to add 10. And we have 38 equals 2x. And x equals 19 if we divide by 2, right? So if x equals 19, then this statement is accomplished. So now let's go to the second statement where we have BE, which is 2y plus 16. Oh, let me be consistent. Let me write the second statement, which is the measure of segment BE. It's equal to the measure of segment ED. So now we can write the equation, and we're going to have 2y plus 16 equals 4y minus 18. And I'm going to subtract 2y here to get rid of this 2y. Of course, there is another way to do it. So we have here 16 equals to y minus 18. I'm going to add 18 on both sides. And we have here 34. And I apologize, this is only 8, not 18. So let's be sure that we do have the correct thing. So this one will be 24 equals 2y, and divide by 2, we have y equals 12. So for this value of y equals 12, these two segments are going to be congruent. So therefore then we have one of the theorem that allows us to prove that this quadrilateral is a parallelogram. The diagonal bisect each other. Let's take a look to this example. Of course, we need to use some algebraic skill. We need to find the value of x and y so that each quadrilateral is a parallelogram. So let's take a look to this A. And the first thing we notice here, we have something that we had just a while ago. We have the fact that AB is congruent with DC. So now what else we need to know in order to prove that this quadrilateral is a parallelogram? We should know that these two sides are also parallel. Okay, so how can we prove these two sides are parallel? If these angles are congruent, then we use the converse of alternate interior angles, and then we know AB is parallel with DC. So basically that's gonna be my statement here. Angle ABD congruent with angle CDB, and if we have this statement, then of course AB will be parallel with DC by the converse of alternate interior angles. So obviously here the measure of angle ABD should be equal of the measure of angle CDB. So now the equation is simply 3x plus 12. 3x plus 12 equals 6x plus 36. So yeah, the first part is nothing else than geometry, where we justify why we can write this equation. And then I'm going to subtract 3x to get rid of the 3x on the left side, and then we have 12 equals 3x plus 36. And you know what, we should make this one minus 36 here, so it makes sense, this problem. Apologize for that. Other than that, we're gonna get an x that is negative. So I'm gonna add 36, and I have 48 equals 3x. Divide by 3, get x equal 16. So for x equals 16, we're gonna have these two angles congruent, which means AB parallel with DC, but also they are congruent, so then we know ABCD is a parallelogram. Okay, let's take a look to part B. Very similar problem, right? So if you start by writing the equation 4y minus 12 equals 6y minus 40, that's correct, that is good, but I want to be sure we justify, we notice these two sides are parallel. Also, they need to be congruent in order to have a parallelogram. So that's the reason we can write these statements. MN needs to be congruent with LK. And then, if you remember the theorem, if we have a pair of opposite sides congruent and parallel, then we have a parallelogram. I will subtract 4y here. And I have here negative 12 equals 2y plus minus 40, sorry. I'm going to add 40. And that will be 28 equals 2y. Divide by 2, and we have an y of 14. So for y equals 14, the sides MN and LK are going to be congruent. They are also parallel. We see that in the picture, and therefore MNKL is a parallelogram. Okay. In my next part of the lesson, we will look a little bit on how to work with quadrilateral in coordinate planes. And we have this formula, the distance formula. How it's called is right here. If you don't remember the distance formula, you may want to use the Pythagorean theorem if that is possible. Then you have the slope formula and the midpoint formula right here. With these three formula, you can determine if a quadrilateral is a parallelogram. And let's take a look to this problem, this example. And we said determine whether ABCD is a parallelogram. Okay, so we have different choices here. I'm going to use this slope formula, and I'm going to find the slope of AB. If I'm looking to the slope of AB, and since I have the picture, I can use this triangle. I have a rise of 1, 2, 3, 4, and a run of 1, 2. So 4 over 2 it's going down from left to right, so it's negative, so it's going to be -2 if we simplify. Now let's take a look to the slope of the other side, of the opposite side, in fact this one, CD, and again we can draw this triangle. 1, 2, 3, 4, and 1, 2, again is going down, so we get the same number. So now based on these two statements, they have the same slope, we can say AB is parallel of CD. Now let's take a look to the other two sides, and I'm going to start with this AD. What is the slope of the segment AD? And you can count because you have a picture. 1, 2, 3, 4, 5, 6, 7, 8, 8. Oops, this is the run, so it's gonna be over 8, and the rise is 1, and it is positive because it's going up from left to right. So that's it, nothing else to be done. Let's take a look to the slope of the side BC. And you'll notice it's going to be the same, right? Because I have a rise of 1 and a run of 1, 2, 3, 4, 5, 6, 7, 8, right? So it's going to be 1 over 8 is going up from left to right. So we notice these two are the same. That allows us to say BC. The segment BC is parallel to the segment AD. Now, based on these two statements, we can say ABCD is a parallelogram. Okay, so this is like a coordinate proof. We use formulas in the coordinate grid, and we prove that these two opposite sides are parallel. So that is the definition of a parallelogram. Let's take a look to this one, and on this one I would like to do here we have point D is 4 and 1, not 6 and 1. Okay, so on this one my first piece of advice is draw the picture if possible. It's gonna take you some time, but still it helps. But let's try to do without drawing the picture, and I'm gonna find the midpoint of the side of the diagonal AC. So that means I'm gonna look just to point A and C. Okay, and I'm gonna have here, and let me organize a little bit different. So okay, so we're talking about AC. So the x coordinate of the midpoint, which I'm gonna call it XM, will be, and if you remember the formula was x1 plus x2, so it's gonna be -3 plus 5 divided by 2. That will be 2 over 2, and that will be 1. Well, let's find the y coordinate of the midpoint, and that will be, we add the y coordinates, this -2 and this 6, and that will be 4 over 2, which will be 2. So this midpoint here is going to have the coordinate 1 and 2. Well, we're going to do the same thing for the other diagonal BD, and I'm gonna call it XM. It might be the same, it might be different, but I'm gonna call it the same. But like I said, I want to give you a warning. Sometime you may want to change it, don't just to get confused. Okay, and we're gonna do the same thing. We're gonna add the x coordinate of point B, -2, and point D, 4, -2 plus 4 over 2, that will be 2 over 2, that will be 1. And the same for the y coordinate of the midpoint of segment BD, and we're gonna add the y values, the 3 here and the 1. 3 plus 1, and we're going to divide by 2, so that will be 4 over 2, that will be 2. So we notice we get the same. If it's the same, that means A, B, C, D is a parallelogram. If they are not the same, that means it's not a parallelogram. And let's see a little bit here. Why? Look at here. This is this diagonal. And this is this diagonal. I'm gonna try. Okay, you see it? Okay, it should be something like that. This is the midpoint of those two segments. Yeah, if they is not the same, then it's not a parallelogram. And again, I want to remind you one more time, the point D is this one, not this one. Okay, mistake there. So this is a way to prove the parallelogram, the quadrilateral is a parallelogram, looking to a property of what the diagonal bisect each other so they have the same midpoint. On my next example, which also is on a rectangular grid, we have a kind of an application. We have 4 drones are flying in a formation. 3 of the drones are shown. Yeah, we see them in the picture. Find the locations, so it might be more than one. Good answer. Of the 4th drone, such that the location of these drones form the vertices of a parallelogram. And the first one, it's kind of a common sense. If you take a look here, you can approach it in a different way. You see here, I have to go 3 down and 1 right. Right, 1, 2, 3, 1. If I do the same thing, 1, 2, 3, and 1, this is the location that one of the location we can have for the 4th drone, right? So I'm gonna say here one of the location will be, let's say, point A, which is 2 and 3. And again, you see how simple it is if you have a picture. But also you can use some algebraics here. Don't forget about the slope. But can I have another situation? And the other two, unfortunately, cannot really see them on the graph paper. I have, but of course, if you have your own graph paper, then you can do a better job. And guess what? I can have a position like this, go 1 left and 1, 2, 3. You see, we can have the drone right here, and then we still have a parallelogram. That will be a 2nd position. Now let's see how we can get the coordinates. So looking to this drone here, the x coordinate is 3. I'm gonna move 1 right, so that will make it 4. But also I'm gonna move the y coordinate, it's 6, and for the other drone here it's 3 up, so 6 plus 3 is 9. That will be another position for the 4th drone, so you can form the formation will be a parallelogram. And do we have another one? Yes, the answer is yes, we have a 3rd choice. Let's take a look how we get this 3rd choice. And if you take a look then let me erase these guys here so we don't get confused. I can go 1 down and 1, 2, 3, 4, 5. So 1 down, 1, 2, 3, 4, 5. That will be a 3rd choice for the drone, and you're gonna have a parallelogram. So now let's see if we can get the coordinates. Okay, so let's start with the x coordinate. We move 5, if you remember 5 right, so from 7 should be 12, and we move 1 down, so from y of 2 we're gonna have 1. Okay, so these are the 3 possible choices for that drone to form a parallelogram. On my last part of the lesson, we're gonna do some proofs, and we're gonna do some proofs about the theorems we discussed at the beginning. If you remember at the beginning, I said if the diagonal bisects, if we have a quadrilateral and the diagonal bisects, then the quadrilateral is a parallelogram. So now we're gonna do a proof here. So let's see how that works. You see the first statement says AC bisects BD, right? A statement here. So let's see, AC bisects BD, that means these two segments are congruent. The second statement, this one, says BD bisect AC, so which gives us these two segments are congruent. So my first thing was to mark on the picture these two corresponding congruent parts, but also we have some congruent angles. We have these two angles congruent, vertical angles. Obviously these two are also congruent. So now you have choices here. You can prove either the triangle AEB congruent with triangle DEC or the other two and move from there. Okay, and if you prove that, then you kind of have everything you need to prove that this quadrilateral is a parallelogram. So let's start, and I'm gonna start to and I'm gonna do a flow chart here. So we have AC bisects BD, segment BD. Okay, so what's the reason for this guy? You see I put a box here, it's given. Based on this statement, I can draw an arrow and put my very next statement, which says BE congruent with DE. And what's the reason of this statement? Is definition of bisecting, right? Or bisector. Okay, very similar I'm going to say about the second statement. BD bisects AC, which is also given. And that means AE congruent to BC. Again, this is the definition of bisector. And if you remember, I said about those two angles being congruent, angles DEC. Let me start with the other one, AEB congruent to angle CED. And the reason for this statement is that these are vertical angles, or you may want to remember, vertical angles are congruent. Okay, and because we have these three statements now, we can write another one about those two triangles. The top and the bottom, let me call it like that, triangle AEB congruent with triangle CED. And what's the reason here? The reason is right here in this part. You notice we have the sides, two corresponding sides congruent, and the anglet included. So that will be side, angle, side. Let me box this first. And we have side, angle, side. Now, based on the fact that these two triangles are congruent, I can write two statements. One is that AB and DC are congruent. And the reason for this statement is corresponding parts of congruent triangles are congruent. C, P, C, T, C. One more time, corresponding part of congruent triangles are congruent. But also, I can write another statement. Which one? Let me put that down here. Like this. I can write angle ECD, this guy, and these guys are congruent. So angle ECD congruent with angle EAB. And the reason of this is the same like for the previous statement. Corresponding parts of congruent triangles are congruent. Of course, we can write another part, but we don't really need it. Now, based on this statement here, because these two angles are congruent, I can say AB, segment AB, it's parallel with segment DC. Why? Because these two angles, if you take a look, are alternate interior angles. So this is in fact the converse of alternate interior angles, which says if two alternate interior angles are congruent, then those two lines are parallel lines. But now let's take a look to these two statements we have here. It's the same. So these two sides are congruent and they are parallel. If you remember, we have a theorem that allows us now to say A, B, C, D is a parallelogram. And the reason is a theorem we just had at the beginning of this lesson. One pair of opposite sides are congruent and parallel. And that was one theorem we just discussed at the beginning. Of course, you can do this proof in a different way. You can prove these two also are parallel line, and then use the definition of a parallelogram. Okay, so it's not an only one way. My next proof is going to be about another theorem we discussed at the beginning. You notice here we have AB congruent with DC and AD congruent with BC. So now, if you remember, the theorem at the beginning of the lesson says if a quadrilateral has two pair of corresponding congruent sides, then it's a parallelogram, right? But now we're going to prove it. We're going to do a proof about that. And for that reason, I'm going to draw this diagonal. You can draw the other diagonals also. It really doesn't matter. I'm going to draw these diagonals. And now you notice you have two triangles. We have the triangle ABC and triangle CDA. These two triangles are congruent by side. This is a common side reflexive property. And then, obviously, these angles are going to be congruent. Corresponding part of congruent triangles are congruent, and then these two angles are going to be congruent. And then we have those two corresponding congruent sides are also parallel sides, so we have a parallelogram. So now let's put them, and again I'm going to use a flowchart, but of course you can use a two-column proof. So let's start with what is given, which says AB congruent with CD. I'm going to box this, and this is given. Then we're going to have the second statement, which is also given, AD congruent with BC and this is also given. Now, only thing I'm going to add here in this moment is going to be what? AC congruent to itself. It's a common side. If you remember, this one has a name, is called reflexive property. Reflexive property of congruence. And now we have these three corresponding congruent sides, so we can write another statement. What triangle ADC congruent to triangle CBA, and you really need to be careful here to have the corresponding letters, and the reason is nothing else than side, 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 the three corresponding congruent sides. Now, based on this one, I'm gonna write what? I'm gonna write one statement. This one, angle DAC. I start with that one. DAC. Let me be sure we can read that. DAC. DAC congruent to angle BCA. Okay, let me box this, and why we can write this statement, what's the reason? I just mentioned corresponding parts of congruent triangles are congruent. But also we can write another statement very similar, angle ACD, we're gonna need both, congruent with angle CAB. Of course, we can write a third statement, but we don't really need that, the last pair of angles. And again, here is corresponding part of congruent triangles are congruent. Now, from this statement here, we can say what? If these two angles are congruent, then AD parallel with BC, and the reason we can write this, the converse of alternate interior angles. Okay, but very similar. From this one, we can write what? That AB, in fact, I'm sorry, is parallel with DC, and the reason is the same like the previous statement I put. Converse of alternate interior angles. Now, based on these two statements now, we know we have a parallelogram, because what is the definition of the parallelogram? The parallelogram is the quadrilateral that has two pair of opposite sides parallel. And let me box it, and the reason is definition of parallelogram, because that is the definition of a parallelogram, and that is this proof. Let's move to one more. On this one, we notice we have AB congruent to CD, so again I'm going to mark them the same way, but also they are parallel lines. So is this a parallelogram? We're going to do that proof, and again I'm going to draw a diagonal, it doesn't matter which one. Okay, let's see this one. Okay, and now what do we see here? These two sides are congruent, this is a common side, and also these two angles, this angle, these angles are congruent, they are alternate interior angles. They are angles formed by the two parallel lines and the transversal, which is DB. So we have two congruent triangles, and from there I think it's pretty easy what we need to do. So let's start, and again I'm going to do a flow chart. Well, of course you can do a 2-column proof. So I'm going to start with the first statement, the second statement, in fact this one. AB parallel of CD, that was given, that is given. From this one, I'm going to write that the two angles I mark them already are congruent. Angle BDC congruent with angle DBA. And the reason is these are alternate interior angles and they are congruent. Okay, so the next statement will be the first statement given, AB congruent to CD. And it was given. My next statement will be that common sides BD or DB, whatever you want it, BD congruent with itself. And that will be reflexive property. And from these three statements, remember I said we can write that these two triangles are congruent. Which one? Triangle ADB congruent to triangle CBD. And why we can write this statement is because simply we have what is called side angle side, right? The two corresponding congruent sides and the angle included. And very similar to what we did before, now I'm going to write what? Angle AP, I'm sorry, angle ADB, this angle, it's congruent to angle CBD, this angle. And the reason for writing this statement is corresponding parts of congruent triangles are congruent. Okay, and now we know we did this already. Now based on the converse of alternate interior angles, we can write AD parallel with BC. And this is the converse of alternate interior angles. If the alternate interior angles are congruent, then the lines, in this case the segments, are parallel. So I'm going to write one more time the first statement given to us. AB parallel of CD, and that was given. And now, yes, we have a parallelogram because we see these two pairs are, two opposite sides are parallel. So yes, ABCD is a parallelogram. And the reason is very simple. This is the definition of a parallelogram. Okay. And one more proof and we finish today's lesson, which is about proving quadrilaterals some quadrilaterals are parallelograms, not all of them. And in this one is the last one. And in this one you notice we have angle A congruent to angle C that is given, and then angle B and D are congruent, and now we're gonna prove we have a parallelogram. So let's see how we do that. And we're gonna start with what is given, angle A congruent with angle C given. That tells us the measure of angle A equals the measure of angle B. That will be the definition of congruent angles. Very similar, I'm going to write the second statement, angle B congruent to angle C, and again not C, D. And the measure of angle B equals over the measure of angle D. Again, the same thing, definition of congruent angles. Okay, now I'm going to write one more statement. Well, what is the sum of the measure of the interior angle of a quadrilateral? That will be 360. Right, so let me write that here. The measure of angle A plus the measure of angle B plus the measure of angle C plus the measure of angle D equals 360 degrees. Okay, let me put a big box here, and the reason sum of interior angles of a quadrilateral is 360 degrees. Okay, so now look at here what I'm going to do. I'm going to write two statements from these three statements. I'm going to write two statements. You're going to see them in a minute. First of all, I'm going to write first of all, this one, I'm going to do a substitution properties, and the first one I'm going to write it here, the measure of angle C. So I'm going to replace this angle A here with angle B. I'm sorry. So I'm going to have the measure of angle, and no, I was correct. I have a mistake here. This was C. So I'm going to replace angle A with C. So the measure of angle C plus the measure of angle D. So this angle B here, I replace it with angle D. And then I'm going to copy the rest of. Okay, measure of angle C plus the measure of angle D equals 360. And again, the reason I can write this one is substitution property. I replace the measure of angle A with the measure of angle C, and the measure of angle B with the measure of angle D. Okay, substitution property. Now, very similar, I can do another substitution. I'm gonna replace angle A with C, but I'm gonna keep now angle B, and I'm gonna replace this angle D now with angle B. So you notice my goal was here to get rid of two of the four angles and keep this statement only two angles. So in the first one I have just angle C and D, and the second one I have C and B. both of them are nothing else than substitution property. And for me, it's some kind of an algebraic step. So on the first one here, I'm going to write twice the measure of angle C, right? You see you have twice the measure of angle C here, plus twice the measure of angle D equals 360, right? This is twice the measure of angle D. And what did we do here? We add, right? So I'm going to write here addition property. Addition property of equality. Then I can do a division here by 2, and I'm going to have the measure of angle C plus the measure of angle D. Oops, this one was 360, will be 180 degrees because I divide by 2. And I'm going to write here division property. And what's the meaning of this? Angle C and D, this angle and these angles are supplementary. Oh, that means AD it's parallel with BC, and that will be the converse of the consecutive interior angle or same side interior angles. I'm sorry, converse, I said yes, converse of consecutive interior angles, and which says that if the angles are supplementary, then the two lines are parallel lines, two segments in this case. Very similar here. I'm gonna write twice the measure of angle C plus twice the measure of angle B equals 360. So addition property. Then we're gonna divide by 2, and we have the measure of angle C plus the measure of angle B equals 180, because we do the division property. And now obviously from here I can draw one small arrow, and I'm gonna write another thing, AB parallel with DC. And it's going to be the same converse of consecutive interior angles. Now from these two statements, yeah, we can write the final thing. ABCD is a parallelogram. And I'm sorry, I'm gonna put it in this corner like this, but that's it. And the reason is very simple, definition of parallelogram, right? And that's it for this last proof. If you enjoyed this lesson, don't forget to click the like button and come back on C-Square for more help. Thank you.